Okay, today Leetcode daily and repeated elements in size to an array. So this one is pretty easy, I would say. There are like two n numbers, and then it has like n plus one unique elements, and exactly one amount of nums is repeated n times. So I can think about a couple of solutions. The first solution is based on default dictionary. So I create the frequencies, or like not default dictionary, like preferred solution, counter-based. So I create a counter for every number goes through counter, check which number has a frequency greater than 1, and then return that number. That's going to be the output. So the time complexity for this one going to be O of n. The space complexity going to be O of n. So this is the second solution. Is a set base. So I go through numbers, and then I have like two branches. If number is in set, then return it. So it's going to be the output. And then if number else, so if the number is not in set, then add number into set. So the time complexity for this one gonna be, again, in the worst case O of n, and the space complexity gonna be also O of n. The benefit here over the previous one is that not in all cases I would need to do O of n iterations, and like not in all cases I'll have like space complexity n. So if I see the number, if I incur a number in the middle that like has already been seen, then I'll return immediately, and then it means that the time complexity gonna be, let's say if I see that in the middle, gonna be n over 2, and the space complexity for that one gonna be n over 2. If I see, so the number of operations gonna be, like the memory in this case gonna be n over 2, and then the number of operations gonna be n over 2. If I see that in the middle, or if I see that at the start, like say the second element, it's already the duplicate. So in this case, the number of operations is going to be just 2, and then the memory going to be also like 2 elements, or there, like 2 units. While in the first solution, I need to go through all elements to create the counter. So even like if there is a duplicate, there's a second element to duplicate. To create this counter, I need to go through the all elements and then like go through the all keys again in the map and like in a counter, and figure out like which frequency. Not through the all keys, but like through the, like I need to go through the keys until I see the frequency greater than 1. So like this case is gonna be O of n like in all cases, and like gonna be time complexity and here like this time complexity will depend on a sample, on the input, and the memory will also depend on the input. So the third solution I can think of is just to go through the array and then like for this one, for the current number, I go through the remainder and like check if there are duplicates. So it says I have a first number, so I go through the n-1 number and check if there is like repeated number that's equal to the current one. And then if there are no, I go to the next element, the second element, and check if there are like duplicated n-2 elements, and then so on and so forth until I reach the end of the array. Until I find the duplicate, but like probably I'll find the duplicate somewhere on my way there. So this so the space complexity in this case gonna be O of 1, and the time complexity gonna be O of n squared. So there is trade-off. Either I can use so this time complexity gonna be O of n squared, and the space complexity gonna be O of 1. So there is a trade-off in all the solutions. I either can like have the space complexity of n and time complexity of n, or like I can have like space complexity of 1, but then time complexity can be n squared. Yeah, so let me implement all this. How much time I have? So I have already spent like 6 minutes. Let me wrap up and do the implementation. So the first one is based on the counter. I'll have the counter and for the nums, and then let's say gonna be a map, and then I'm gonna go for key. Let's say key in m. I'm gonna go if m key greater than 1, return key, and then return -1. That's gonna be the first solution. The second solution is gonna be based on the set. Let me check what's the submission. Okay, so like time not good, space better, but still can be improved. It's interesting because like space is like P84, or like it beats like 84% of other solutions, so that's interesting. So if I do the instead of a set, instead of counter, I'll use a set, and then I'll check if I go now for the num in nums, and then I check if num in set. I'm gonna return num, and then otherwise I'll add this num to the set and do again. Submit. Okay. Time becomes better. Space, not what I wanted it to be. I thought that the counter will be okay. The space now is better. So I'll do some variation of this set. So I'll do this because the values are limited in range of their values. So the maximum number can be 10 to the power of 4. So I'll create this array of 10 to the power of 4 plus 1, and then I'll check if they call it a, and then if a num greater than 1, if a num is equal 1, I'll return num. Otherwise I'll do a num is equal 1. And then let's check this one. Yeah, it's all over the place. If I do one-liner, what is gonna be? Can I do one-liner here? No, let me do the third approach when I have like that. For, let's say, n is equal len nums, and then for I in range n, and then for j in range I plus 1, and then n, and then I'm gonna check if nums I is equal nums j, I'm gonna return nums I. No? Interesting. Okay, -1. So why it is not going to yield the last one? So let's just print I and j. I and j. So 1, 2, 3, 1, 2, 2 and 3. 2 and 3. Ah, okay, I should I forgot to do return. Okay. Yeah, the time is not good one, but the space is much better than any other solution. If I do some kind of say for I in range n-1, and then for j in range in range. Can I do this one? For range in I. Can I do this one plus 1, something like this? So I have initially 4 I in range n-1, and this will generate the I. And then I need to do for j in range from that range. In range can I do this one plus 1 and then up to the end? And nums. Okay, I'm gonna do nums I if nums I is equal nums j, whatever, like I don't wanna like confuse now. So say we have this solution as a third solution. Maybe I can ask ChatGPT to make the comprehension out of it. Let's check. ChatGPT, can you make a list comprehension out of next solution? Oh no, that's not what I wanted. But it's worse than optimal. Why? Yeah, this one, the next function is kind of confusing. What is next function? So it's iterator. Oh. Okay, so that's a pretty cumbersome. Let's check if that's gonna be the better. I like this one maybe. Let's try this one. Okay, the time complexity is still not the optimal. Okay, let's check the editorial. The counter, okay, then compare, and this is gonna be the what? Repeated n times. Off, and that's interesting. So this one is not unless with a neighbor that are distance 1 and 2 and oh, that's the interesting one. So because they say, okay, there is a neighbor, like at least half of them the elements, or like half of the elements are gonna be equal to each other. I'm saying that like even if I gonna check for I in range n minus 1 and say we have n is equal to n nums, can it be like from 1 if nums I minus 1 is equal to nums I plus 1, return nums I minus 1, otherwise returns minus 1. Or nums I is equal nums if nums I is equal nums I minus 1, return nums I if nums I is equal nums I plus 1, return nums I. Okay, that's an interesting one. So you should check also distance to. That would be interesting to prove why it's gonna be like distance 1 and then distance 2. If I do the check if I have this set as equal nums so window size 4 here. And range in I, and then I'm gonna have set equals set, and then s dot add nums I, and then say if nums I in set, I'm gonna return nums I, otherwise as add, and then as remove nums I minus 1 or minus 4. So it's here, yeah, and then if I is greater or equal 4, will it be enough? Return minus 1 in the end. Yeah, this will be enough. Memory is optimal, time is optimal. Yeah, this is O of n and O as time complexity. So the time complexity gonna be O of n, and the space complexity in this case gonna be O of 1. What if I have like 3? Oh, yeah, I have already counterexample that 3 won't work. Yeah, that would be nice to prove why it is so. Ah, okay, so in a 4 elements array, Yeah, that would be nice to read that. I'll read that later. Okay, that's gonna be it.